That's a ring stand. See the ring on the ring stand? That's the ring. Okay, anyway, let's get back to this. All right, so we're going to talk about ionic bonding now. Okay, so far we've spent a lot of time talking about covalent bonding, which is all about sharing electrons. Okay? And now we're going to talk about ionic bonding, which is due to the attraction of particles that have opposite charges. Now don't get confused by that, because opposite charges in this case means I can have many kinds of positive charges and many kinds of negative charges. But it's the positive charges, all of them, that are attracted to all the negative charges. Okay? So it's not like it's one positive attracted to one negative. It can be three positive attracted to one negative, but you just need three of them. All right? So let's go back to orbital notation here, and let's take a look at a couple really simple things. Hydrogen. We could do hydrogen. Sure. Well, it's really simple. Sure. So here's hydrogen. Here's orbital notation for hydrogen. 1 electron. Okay. Now, on rare occasions and with special conditions, hydrogen can gain an electron. Okay, but usually what it does is it's going to give up an electron. Okay, so when we ionize hydrogen, what we get is basically an empty orbital. Okay, well, if I get rid of an electron, and not a negative, the electron's negative. If I get rid of the electron, I have one proton in the nucleus, no electrons. What's the charge? Positive. And in fact, sometimes we call a hydrogen ion a proton, because there's nothing left once you take the electron off. You already got the proton for most hydrogen atoms. Huh? Like I said, you can do that in rare cases. It doesn't happen very often. Okay. Now this is what happens most of the time with acids. Acids actually make protons that you mix up in some solution like water, or in some liquid. Presumably most of the time it's water. Okay. All right. So say I have a hydrogen ion. Okay, and let's put it with I don't know, fluorine, because that's kind of simple. So here's a fluorine atom, or the orbital notation for a fluorine atom. And I hope you know how to do this. I've been over it mucho times, and there's plenty of videos on YouTube that I've put there for you to go back and review. If you need individual help, please come and see me. I'll be glad to help you. Okay? So fluorine is almost completely full in its valence level. All right? It only needs one more electron to be like neon. And fluorine's aspiring to be like neon. Okay? So fluorine then, when it goes through ionization, okay, that's what we're talking about, ionization. So we're going to add one more electron up here. Yes, it would be negative. You're right, because we're adding an electron. Electrons are negative. Now just to show where it's going, I want to make this last electron in red just to show we're adding an electron on there, okay? Nothing special about the color coding here. I'm just trying to make sure you're clear about where it's going. All right? But now if we add an electron on there, fluorine originally had 9 protons, so a fluorine atom also has to have 9 electrons, but this fluorine now has 10 electrons. So it has a negative charge, one more electron than protons. So we're going to put a negative charge on here. If you don't put the negative charge on there, it's not complete, and you lose points. Okay? You never know. Quizzes. I don't announce quizzes in advance. All right? And Reema's back there saying, "Don't give me any ideas." Okay. All right. So then the hydrogen ion since it lost its one electron, okay, when it ionizes, it just becomes H+. Right?
What is the little dot?
That's the electron dot. This is electron dot formula here.
Oh.
Okay. So if we lose that electron, it becomes H+. Now fluorine over here started out with 2, 4, 6, 7 valence electrons. All the electrons in the highest energy level, you count them up, 2, 4, 6, 7. 1, 2, 3, well, I should have put one on each of the 4 sides and then start pairing them up. I end up with something like this. So that's a fluorine atom. Okay, and we're going to add an extra electron on there. I'm going to make this a little red dot just to show that's what we're doing. Okay, and that's going to give it, this is going to be our fluorine ion now. Actually becomes a fluoride ion because it's negatively charged. We did that in the last unit.
So when it's positive,
Well, when it's positive, you just call it what it is. Hydrogen. Or proton. Okay, hydrogen ion. Alright? Fluorine, when you make it negative, you call it a fluoride. Alright? But now to show the negative charge, you usually put this in brackets to show the negative charge applies to everything. Not just to, if you put it near this electron right here, somebody might think, well, that's just applying to that electron, but that's not the point. The point is the whole ion is negatively charged.
doesn't matter what side you put it on.
What? Yeah, you put it up in the upper right. Charges go to the upper right. Okay? And there's a point in all this. When we were doing nuclear symbols, the mass went in the upper left. The protons went lower left. So now the charges go upper right, and numbers in the lower right tell you how many of those there are bonded in some structure. Okay? So we do H2O. The 2 goes down here to show I have 2 hydrogens. That's what that means. Okay? So each of those corners are designated for a certain purpose. All right? Now, so now that we've got an ion, let's just write the ion symbol. The ion symbol is simply this part right here. So here's the ion symbol for fluorine or fluoride. Here's the ion symbol for the hydrogen ion. So these are ion symbols. Okay? And if I have a plus charge and a negative charge, it evens out. That makes sense? One negative, one positive, and they'll form a compound like this. So this is an ionic compound now.
So what is that?
This is called hydrogen fluoride. If we want to discuss it as a molecule, when we dissolve it in water, it becomes hydrofluoric acid. It's highly poisonous. And there really isn't any antidote. Okay, you get it in you, you're done. You cook, you're toast.
How long?
Huh?
How long?
How long for what?
So you got to
Depends on how much you have. A very, very small amount probably wouldn't hurt you. Very, very small amount. But this stuff is really, this is really insidious and crazy, man. You get this stuff, you get a strong solution of this in water and put it on your skin. Just the nature of these ions are so weird that they will burn your skin without you feeling it. Because it sort of short circuits your nerve endings. It's weird. It'll burn. They say it'll burn you right down to the bone. You won't even feel it happening.
That seems cool.
It's not cool. It's not cool at all.
It's not cool, but it's cool. No, it's pretty cool.
No, it's not cool. You don't. They won't even sell it in the stores anymore. It used to be you used to be able to buy it in the grocery store to remove like rust stains from clothing and stuff, but they've taken it off the shelf. They don't sell it anymore. Okay, you can't buy it. I'm not sure. I mean, I could buy it, but that's because the school has a special license for things like that. Okay, but I don't have any need for it, so I'm not going to buy it. Okay, unless I get really tired of cars and want to get rid of it. No, I'm not going to do that. No, I'm sorry. That's a bad joke. That's a bad joke. I know. But everybody, I can hear you guys all laughing. You all know I'm just kind of joking around. I don't really mean it. Okay, I'm just playing around. All right. No. Connor's my favorite student. I wouldn't want to get rid of him. Okay.
Can you make it?
Can you make it?
Yeah.
I don't know of a way to make it. There probably is a way to make it, but I don't know how to do it. All right, now. All right, so let's move on now. Let's do something different. Let's say we've got beryllium then. Okay? And we're going to put it with fluorine. All right? So beryllium's ground state is 1s, 2s, okay? And to become an ion, it's most likely going to get rid of these two electrons right here, so it'll end up with the same orbital notation or electron structure as helium, one of the noble gases. Everything wants to be like a noble gas, right? Okay? Now, if you didn't know for sure how many it wants to give up, well, you look on that periodic table I gave you. I gave you a cheat sheet. Right here, 2 plus. Okay? Kind of a cheat sheet here, okay? So it's going to go to being beryllium, 1s, both electrons from 2s are gone. What's the charge on the beryllium? Positive 2. We got rid of 2 electrons, it's 2 positive.
Well, why can't it just say 2s?
Well, it could, but when it bonds, it doesn't. Okay? So then that beryllium ion, since we got rid of both of the valence level electrons, so beryllium started out as Be with 2 electrons, and we ionized it by taking away both electrons, both valence electrons, so it becomes just beryllium 2 plus. Okay? All right. Now fluorine, we said a moment ago, was this. So that's the ground state. We ionize it. It becomes fluorine with a 1 negative charge because we're going to add an extra electron on here. I'm kind of speeding through fluorine because we've already done it once. Okay. So the fluorine then, to ionize it, in terms of using electron dots, I want to have one lone electron. One lone electron, but I want to add an electron to it to get the fluorine ion. And we end up with a fluorine with a negative charge. Okay, now the symbols then, Be2 plus, the ion symbols, and F negative, okay? I need to be able to come up with a molecule, or not a molecule, I'm sorry, because this is not a molecule. Molecules have covalent bonding. This is going to be an ionic formula. I have to have 2 fluorines. The only way to get the charges to even out, to have a neutrally charged compound. That's what we're aiming for. A neutrally charged compound. Okay? We need 2 fluorines. Does that make sense to everybody? We've got to get the charges to all even out. And we'll end up with BeF2. And we call it beryllium fluoride.
How do you get another fluorine?
What?
How do you get another fluorine?
Well, it's not on the paper here. I'm saying to make the compound neutral. And that's what we're aiming for. We need another fluorine.
So you don't have to do all that over again?
No. Now just show me how we get the negative charge is all you have to do. That makes sense to everybody? So that's not so bad, is it? Let's let you try one then. Mm-hmm. You want me to put it back up there to ask a question? You want to ask a question about this?
No, I was going to ask you if you had to take the SAT.
Did I have to take the SAT? Yeah.
Was it easy?
I wouldn't say it was easy. It's hard for me as it was for you. Only back then they didn't have the written part. I think you didn't have to write an essay. Okay.
I'd say it was easy though.
Huh? Oh. And back then they didn't have all these SAT prep stuff. I wasn't able to take a PSAT. Anyway, so here we go. There is no failing. Sodium sulfide. The what? Sure. How about that? Does that work? My older two sons have gone to college. Yes, he went to college. He actually is a teacher. He went to USC upstate. He went to USC in Columbia for a while. He went to, let's see, Spartanburg Methodist for a while. Which, the older son, he went to Clemson for 1 year and then the College of Charleston for the remainder of his college work.